Hello, grade 6. Our science lesson for this week is about organic chemistry. And throughout this lesson, we are going to see how does carbon form molecules. And by the end of this lesson, you should be able to describe how carbon forms many of the molecules essential to modern materials and living things. So first of all, let us start our lesson by learning why does carbon form many different compounds. Take a look around you. Nearly everything that you see contains carbon in one form or another. Most atoms can form bonds with other types of atoms. Carbon has the ability to form bonds with other types of atoms and bonds with other carbon atoms too. The structure of a carbon atom allows it to form molecules in a wide range, sizes and shapes. Now, let's begin our exploration by taking a closer look at a carbon atom. So first, a carbon atom has 4 valence electrons. The secret to carbon's ability to form a wide variety of molecules lies in the arrangement of its electrons. A carbon atom has a total of 6 electrons arranged in 2 energy levels around its nucleus. 2 of these electrons are in an inner level. The 4 electrons in the outer level form bonds with other atoms and are called valence electrons. Second, a carbon atom can bond with multiple atoms. Bonds between 2 atoms always form in pairs of electrons. Sometimes one atom supplies both electrons in the pair. Sometimes each atom in a bond provides 1 electron to the pair. Carbon atoms form bonds by sharing their valence electrons with other atoms. Because carbon has 4 valence electrons, it can form bonds with up to 4 other atoms at the same time. Now, let's take a look at this picture. It shows a carbon atom. A carbon atom has 4 electrons in its outermost level. These are called valence electrons. Now, let's discover how does carbon form molecules. Molecules are groups of atoms joined together by bonds. Carbon forms molecules by bonding with other carbon atoms and with atoms of other elements. Most molecules that do not contain carbon have only a few atoms, but molecules that contain carbon can involve hundreds or even thousands of atoms. First, carbon can form single, double, and triple bonds. A bond between 2 atoms that is made up of only 2 electrons is a single bond. Carbon can form up to 4 single bonds at one time. Carbon atoms can also form double and triple bonds. What is a double bond? A double bond is made up of 2 pairs of electrons. It means 4 electrons in total. A carbon atom can form a maximum of 2 double bonds. Now, a triple bond is made up of 3 pairs of electrons. It means 6 electrons in total. So a carbon cannot form more than 1 triple bond. We have to know that a single bond is represented by 1 short line between 2 atoms, and a double bond is represented by 2 lines and a triple bond by 3 lines. So if we look at the picture, we can see that in the first molecule, a single bond is formed between carbon and hydrogen. In the second molecule, we can see that a double bond is formed between the 2 atoms of carbon. And in the third molecule, we can see that a triple bond is formed between the 2 atoms of carbon. Second, carbon molecules can form chains. A carbon atom can form up to 4 bonds with other carbon atoms at the same time. This ability to form bonds with other carbon atoms makes it possible for long chains of carbon atoms to form. These chains can spread in a straight line or they can branch off into other directions. The branches may also contain chains which add to the size of the molecule. Let's take a look at this picture. in this model of a straight chain carbon molecule, each carbon is connected to at least one other carbon. Now, let's discover what information does a chemical formula contain. Molecules can be composed of many atoms, and their names can be complex. A chemical formula is an easier way to identify a molecule accurately. A chemical formula is a combination of letters and numbers that have specific meanings. Now, let's see what information does a chemical formula contain. First, the types of atoms in the molecule. The letters in a chemical formula identify the types of atoms in the molecule. Chemical formulas use the same one- and two-letter combinations that are used to identify elements in the periodic table. For example, a C in a chemical formula tells you that the molecule includes at least one carbon atom. An H tells you that the formula includes at least one hydrogen atom. Using chemical symbols lets you show the composition of a molecule quickly. Second, the number of each type of atom in the molecule. A chemical formula also tells you how many of each type of atom is present in the molecule. The number of each type of atom is represented by a number written at the bottom right of the chemical symbol. This number is called a subscript. Let's see what are types of structural formulas. A chemical formula tells you the types and numbers of atoms in a molecule, but not how they are bonded together. A structural formula shows how atoms are connected. We have to know that there are two types of structural formulas, full and simplified. Let's start with full structural formulas. A full structural formula shows all of the bonds between the atoms of a molecule. For example, methanol has the chemical formula CH4O. The formula shows that methanol is composed of one carbon atom, 4 hydrogen, and 1 oxygen atom. If we draw the bonds between each atom, we will see the full structure of methanol. This is the full structural formula of methanol. Simplified structural formulas. Sometimes we need to see how atoms relate to one another within a molecule, but do not need to see every bond. Then we can use simplified structural formula. The atoms bonded to each central carbon atom are grouped together. The simplified structural formula for methanol is shown below. Now we are going to learn about organic compounds. What are they and where are they found? Organic compounds serve many different purposes and are found in both non-living and living things. An organic compound, by definition, is a chemical compound that is composed of carbon, hydrogen, and possibly other elements. Organic compounds are found in non-living things. Many of the non-living things we use every day are made of organic compounds. The nylon used to make fishing line, the special materials used to make waterproof backpacks, and the fuel used for heating our homes are made up of organic compounds. Living things are also made up of organic compounds. Many organic molecules are found in the human body, other animals, trees, and plants. Organic compounds provide energy and structure for living things to grow and change. Now, let's see what other elements make up organic compounds. Organic compounds are usually composed of mostly carbon and hydrogen, but they can also include other elements. These elements include fluorine, chlorine, oxygen, phosphorus, nitrogen, and sulfur. For example, plastic pipes used for plumbing are made of an organic compound that includes chlorine. An organic compound that includes fluorine is used to make non-stick surfaces on cookware. Nitrogen is found in the nucleic acids that make up DNA. Now, let's look at this picture. The periodic table lists all the chemical elements that are currently known. The table contains 18 groups of elements. Here, a portion of groups 13 till 18 is shown, and we can see that fluorine, chlorine, and nitrogen are some of the elements that can be included in organic compounds. Now, let's discover how are organic compounds classified. With so many different types of organic compounds, chemists need a way to keep them organized. They classify these compounds based on their composition and structure. Three of the classes of organic compounds are hydrocarbons, organic acids, and carbohydrates. Let's start with hydrocarbons. A hydrocarbon is an organic compound that contains only carbon atoms and hydrogen atoms. The simplest hydrocarbon is methane, CH4. It has just one carbon atom bonded to 4 hydrogen atoms. However, not all hydrocarbons are this small. Some hydrocarbons have more than 20 carbon atoms. Second, we have the organic acids. An organic acid is an organic compound that has acidic properties. All organic acids contain carbon, hydrogen, oxygen, and sometimes other atoms. Organic acids are identified by a group of atoms called a carboxyl group, COOH. Third, carbohydrates. A carbohydrate is a neutral organic compound containing carbon, hydrogen, and oxygen. Carbohydrates often contain 2 hydrogen atoms for every 1 oxygen atom. Many of the foods we eat contain carbohydrates. Carbohydrates are one of nature's energy stores. Living things break down carbohydrates and use the energy released to grow and reproduce. Finally, to end our lesson, let's see what other structures can organic compounds form. The carbon atom's unique bonding properties allow it to form more than just straight or branched chains. For example, a chain of carbon atoms can curl around and attach to itself to form a ring. Or, the same small unit of atoms can repeat over and over again to form what is called a polymer. Many compounds that we encounter every day contain rings or are polymers. Rings. A ring of carbon atoms can form 3 or more carbon atoms. Some molecules include rings formed from 6 carbon atoms that are connected by alternating double and single bonds. These compounds are called aromatic compounds. Second, polymers. Polymers are molecules composed of the same repeating small group of atoms joined together in long chains. The repeating groups are called monomers. Now, let's take a look at this picture. The structure above is a portion of a plastic called polyvinyl chloride. One of the monomers is shown in the square. That's it for this week, grade 6. Thank you for your attention.